Hi everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Technology. In this session, we are going to discuss about geometric distribution. Here, the probability mass function of geometric distribution is q to the power of x minus 1 into p. Here, x value start from 1 to infinity. Here, p plus q value is equal to 1. P is nothing but probability of success and q is nothing but probability of failure. In binomial distribution, a number of trials is fixed. In Poisson distribution, number of trials are infinite. In geometric distribution, we repeat the trial up to get the first success. Here, we are going to see one problem on geometric distribution. If the probability that an applicant for a driver's license will pass road test and any given trial is 0.8. What is the probability that he will finally pass test on the fourth trial? Next is fewer than four trials. Here they have given probability is 0.8. Here probability value p equal to 0.8 here. And our q value is 1 minus p because p plus q equal to 1 here. So 1 minus 0.8 we get our q value equal to 0.2 here. Now we need to fix the first probability mass function. Probability of x equal to x cube over x minus 1 into p. This is our geometric probability mass function. Here they have given p value is 0.8 and our q value equal to 0.2. Substituting here we get p of x is equal to 0.2 the whole to the power of x minus 1 into 0.8. Now we need to find the probability that the driver's license for a person will finally pass test on the fourth trial. Here let us consider x is the number of trials for getting the license here. So probability of x equal to 4. We need to find probability of x equal to 4. So instead of 4, instead of x, we replace this 4 here. It will become 0.2 the whole power 4 minus 1 and our p value is 0.8 here. So 0.2 the whole power 4 minus 1 we get 0.2 the whole cube. Multiplying these things we get 0.0064 is the probability for he will finally pass on the fourth trial. Now we are going to find the probability that he will finally pass the test on is fewer than 4 trials. That means we need to find the probability of x less than 4. That means we need to find the probability of x equal to 4 plus x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. Substituting x equal to 1 here, it will become 0.2 the whole power 1 minus 1 0 into 0.8. And substituting x equal to 2 here, 0.2 the whole power 2 minus 1 we get 0.2 the whole power 1 here into 0.8. Next probability of x equal to 3. So putting x equal to 3 here, 0.2 the whole power 3 minus 1 we get 0.2 the whole square into 0.8. So 0.8 is common for all the terms. So taking outside anything for 0 is 1 plus 0.2 0.2 the whole square means it is 0.04. By simplification we get the probability that he will finally pass test is fewer than 4 is 0.992. Now we are going to find the MGF of geometric distribution. So already we know the formula. Mx of t is nothing but expectation of e to the power of tx. Here x is the value discrete value. For discrete case our MGF formula is summation of e to the power of dx into p of x. Our p of x value is equal to q to the power of x minus 1 into p here. Substituting p of x as q to the power of x minus 1 into p. Now, here the x value vary from 1 to infinite. X value vary from 1 to infinite. Other x will be treated as constant. So, p and q to the power of minus 1 is constant here. Taking outside p by q into summation of x equal to 1 to infinity. Here power is common for both the terms. So combining together we get q into e to the power of dx. So q e power t the whole power x. So now we need to substitute x equal to 1 to infinity. So putting x equal to 1, it will become q into e power t plus x equal to 2, q into e to the power of whole square, e to the power of t the whole square plus q into e to the power of t the whole cube, etc. So here q into e power t is common for all the term. Taking outside, it will become a1 plus q into e power t plus q into e power t the whole square, etc. This is nothing but 1 plus x square, etc. format. That is, it is the expansion of 1 minus x the whole power minus 1. Instead of x, here we have value q into e power t. So substituting in this expansion, we get 1, it will become 1 minus q into e power t the whole power minus 1. So finally, the mx of t, moment generating function of geometric distribution, is p into e power t divided by, instead of writing whole power minus 1, bring it to the denominator, we get our mx of t equal to p e power t divided by 1 minus q into e power t. Thank you.